Hey everyone, it's Miss Mac here with another short video. This time we're continuing with our second lesson on quadratics, learning about the quadratic formula. We just have one learning objective for this video, that we can solve a quadratic function using the quadratic formula. So you might be wondering, what is the quadratic formula? And here it is. The quadratic formula is x, which is our solution, equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll get into where we get all of these different variables from later on in the video. So far with quadratic functions, we've been looking at functions that look like this one. And with those functions, we've been able to factor these functions into their two binomial pairs. And from those two binomial pairs, we've been able to determine the solutions. And we know that our solutions to a quadratic function are the places where our graph crosses the x-axis. We also call these the zeros and the roots. So our solution to this function is x equals negative 6 and x equals negative 5. But let's look at this quadratic equation and try to do the same thing. So if I were to try to factor this, I would look for numbers that multiply to make negative 8 and add or subtract to make negative 5. If I brainstorm factors of negative 8, I know that some factor pairs are 8 and 1. And 2 and 4. And there's no combination of addition or subtraction that would allow me to make the number 5 using any of these factor pairs here. So this quadratic equation is considered to be prime, which means that it cannot be factored. And you may remember the word prime from previous math classes. If something is prime, that means the only factors are itself and 1. So when we're talking about a quadratic equation that is prime, we cannot factor this like we've been used to doing. So this is where the quadratic formula comes in. When a quadratic equation cannot be factored, we will solve using the quadratic formula. So the quadratic formula is a way for us to find the solutions. Here are the solutions to a quadratic function when it cannot be factored. But before we start using the quadratic function, let's talk about where each of these variables come from that we will be inputting into the formula. So a in this formula, which we see a couple of times here, a is the coefficient of x squared, the coefficient of x squared. Okay, so whatever number is in front of our squared term, that coefficient is our a variable, our a term. Our b, so here you see b a couple of times as well. Our b is going to be the coefficient of our single x term. Okay, so b is the coefficient that will be in front of our single x term. And maybe you could have guessed this, but our c term, which we see right there in the formula, c is the constant term. So this will be the term without a variable. Okay, so we'll use each of these coefficients together to substitute into our formula and ultimately find our solutions. One last thing to point out about this formula is that right here we have a symbol that means plus or minus. And because we have this symbol here, that means we'll need to do this process of using the quadratic formula twice in order to have both of our solutions. So let's get started with an example. Here's the quadratic formula again for our reference, and you'll notice that we're going to start by doing the plus version first. So we will add negative b to everything else on the right side of that expression. But before we get started, we need to list what our a, b, and c terms are. So there's an invisible number in front of x squared. So our a is 1. The number in front of our x term is -5. So our b is -5. And then we have -8. We are subtracting 8. So our c term is -8. Now that I know each of those, I will take them and substitute them into our formula and then use order of operations to get our solution. All right, let's do some substitution. So I have x equals -5 plus the square root of -5 squared minus 4 times 1 times -8 all over 2 times 1. Okay, there's a lot going on here, so let's do this using order of operations. Before I do that, I just noticed I have 2 negative signs together all the way on the left, and that will make an addition sign. All right, so order of operations tells us we need to simplify this exponent first, and then we can do what's underneath the grouping symbols, which is our square root sign. So we have x squared equals 5 plus the square root of -5 squared is 25 minus 4 times 1 is 4 times -8 is -32. Again, I notice I have 2 negative signs next to each other, so that becomes addition all over 2. 2 times 1 is 2. Okay, great. Now let's actually add and simplify what's under our radical. So we have x equals 5 plus the square root of 57, because 25 plus 32 is 57, all over 2. And I notice that 57 is not a perfect square, so I won't get a whole number when I take the square root of 57. But I rounded to 2 decimal places, and I got the square root of 57 to be 7.55 all over 2. So my last step is, or my second to last step is to add 5 plus 7.55, my numerator, and I get 12.55 all over 2. And so finally, I will divide by 2, and when I divide by 2, I get x equals 6.125. So this is the first of my 2 solutions. I'm going to do this process one more time, but instead of having an addition sign up here, I'm going to have a subtraction sign. All right, so let's go ahead and start this half of the problem. So x equals -b. This time we will write minus the square root of b squared minus 4ac, and all of that will be over 2a. So much of what we do about this problem won't change, except that we have a subtraction sign here instead of an addition sign. So x equals -5 minus the square root of -5 squared minus 4 times 1 times -8 all over 2 times 1. Cool. We know this double addition or subtraction sign turns to addition. So we have x equals 5 minus the square root of -5 times -5 is 25 minus -32 all over 2.
Okay, so again, the only thing that's changed is this negative sign. Let's simplify under our radical again. We have x equals 5 minus the square root of 57 all over 2 times 1, which is 2. X equals 5 minus 7.55 all over 2. So we notice now instead of having positive 12 in our numerator, we're going to end up with a negative number. So we have 5 minus 7.55, which is negative 2.55 divided by 2, which is x equals negative 1.275. So this is the second solution to our quadratic equation. The first one was x equals 6.275. So those are our two solutions to this quadratic equation.
And finally, we can confirm the solutions to this function by looking at this graph in Desmos. And we notice that the places where this graph cross the x-axis are the same values as our solutions. So our intercepts, our roots, we also call these our roots, and our zeros are the same values as the solutions that we found using the quadratic formula. All right, everyone, I hope that video was helpful. If you're stuck, go ahead and watch that video one more time. And if you're really struggling, send Miss Mac an email. If you like this video, hit the like button. And of course, if you haven't already subscribed to our YouTube channel, go ahead and hit the subscribe button now. Thanks for watching.